So now we are going to create a triangle to square where main the main code will code up the main thing now. So we are just a lot of things to do. So basically the idea is the animation from the triangle to where square, like we have see three sides, right? For a triangle we want now four sides, so the three sides will change into a four sides. So basically now structure, initially we'll be having four structure, four side, like four vertices, but third, so in the what will generally in a square we have four vertices, and the all are distinct vertices. Now in this thing we'll have four vertices for a triangle, but the first and second vertices will be the same, the rest will be different. So we'll have only three different like we'll have two similar vertices having the same coordinates and two dissimilar vertices. Then only we can have a like a four uh, a structure which will be a triangle even if you have four vertices. Now when we are converting this triangle to a square, uh, we'll change the position of the first and second vertices so that they won't be same. They'll have a like they will move the vertices by equal distance, which will be the half of the other side. So now to change this and this logic, I will moving from 0 to 1. Initially it's a triangle, then we are changing it to a square. So the state change will be 0 to 1. So we'll define this change with the help of a class called state. So this will say how we are changing our state of animation, which is from 0 to 1. So we'll have a constructor and we'll update the state class, the object of the state class. It will take a certain CB which we call stop CB, which acts when we have reached our state, which we call when we have reached our final state. Then we have something called start updating. So let's not have the start updating now. Mm, what we are going to do is now we'll just have something called scale, which will be 0 initially, and previous scale, which indicates the previous scale, the initial scale, which will be 0, and something called dev, which will be 1. So when we are changing the scale, we'll say 0 will change from 0 to 1, and it will take 0.1 steps, and it will be based whether it will go from 0 to 1 or 1 to 0. It will be based on this property called dir, which is this dot dir. And so here's this thing, we are going to 0 to 1, then we also reversing the animation, which is 1 to 0. So when it will be in repeat mode, you'll see it 0 to 1, 1 to 0, 0 to 1, 1 to 0, 0 to 1, 1 to 0, that in that way. So when are you going to stop the animation? Stop the animation means when you are stopping this update thing from 0 to 1 and 1 to 0 will stop there. When it goes from 0 to 1, then it goes to 1 to 0, we are going to stop at there. When it reaches 0, we are going to stop it. So if and when it goes to 0 to 1, we have to also come back to 0 from 1. So we have to change the dir. We have to say -1 of the dir. So we are going to do this by we are going to monitor this by when math of abs of this dot scale minus this dot prep scale. So when it goes to 0 to 1, when the scale goes to 0, when we go to 1, we want there will be certain variation because decimal isn't having the proper 1.000 kind of thing. It will be 1.000 003 004 something like that. Proper precision is not found in JavaScript. So we'll say when it is greater than 1. So if this dot scale has gone to 1, prep scale will be 0. This dot scale, and then we'll set the this dot prep scale as 1, and this dot we'll reverse this dot there. So we are going to reverse. We are going to first say this dot scale will be 1 for us now, like it will be 1 point something 0.34 something like that. Proper 1, we won't get proper 1. So if we do this, we'll get proper 1, and we are going to change the direction. We are going to reverse that their property. We'll do this by multiplying 1 minus 1 to it. Now we'll say prep scale is scale, like see, if you go to 0 to 1, the prep scale will be 0. If you go to 1 to you go from 1 to 0, then the prep scale will be 1 at that position. So this condition must satisfy to stop the thing. Now if this dot, if we see this dot there is equal to 1, then we are going to stop updating it. Okay, so quite straightforward. This may be a tricky at the first sight, but once you get the like practice of it, you can control this. It is like we are interpolating within two states. We are changing from one state to another. So let me explain you what I did here again. So I said scale as 0, we have to move to 1, and prep scale also 0, and this dot dash. So when we are moving to 0 to 1, our direction will be positive. When we are moving 1 to 0, our direction will be negative. So initially, when we'll increment the scale based upon the dead thing, so it can be when you're going to 0, it will be 0 0.1, 0 0.2, 0 0.3, 0 0.4, 0 0.5, 0 0.6, 0 0.7, 1. And since the precision won't be exact, it will be something 1.0003, 1.004. So we are checking for this if it is greater than 1. Like when scale will be 1, prep scale must be 0. And since the precision is not accurate, you have to have greater than, not equal to. Okay, so now to have exact 1 or 0, we have to do this. We have to say this dot scale will be prep scale plus this dot data, which will be 1 if prep scale is 0, and minus 1 if prep scale is 1. So we are reversing the direction. As I said, we have to go from 0 to 1, then 1 to 0, and we are also setting the prep scale as the scale which we got now, so which is 1 or 0 based upon the your del. Now when the prep scale will be 0 and scale will be 0, like we are coming from 1 to 0, that means we are coming from 1 to 0. So del must be equal to 1. As we are changing the dir here, it must be minus 1, but once we multiply minus 1, there is dir is 1. Then we are stopping the update thing, the state updation thing. Okay, now we're going to add this to get no, it's movies directly. Okay, so we are going that directly add, get commit, adding the um, adding state class. Okay, we added it, and now we are going to create this uh, the main class, which will where we will draw and we'll call this update method. So the main class will use the state method. So this is our main thing, this triangle to, let us name triangle this as triangle to square wave. Okay, it will have a constructor, it will have a draw context object, draw method will have to take the context object, it will have an update thing, which will pass a stop cd method. So we are going to use the state class. We are going to create a state object class object. So this thing, so I don't know why I created this. So okay, Okay, so we are going to update state object from this update method, and we are going to pass the callback method when we have to stop the update when we are stopping when the we are going to stop the updating the state object. And now we are the here we have to draw the triangle to square wave thing. So as I said, mm, so as I said, and somehow we have to also use the amplitude and frequency. So we have to also pass the amplitude and frequency. So I will say this as A as M. This is not N as FIC. I am comfortable with A and M. That's why I don't want to use a bigger variable. So now the wave will take the whole width, and amplitude will be like the thing to which to the it will correspond to the total height the wave goes. So we need a certain thing for one square wave. Okay, so I will say it is w by this dot n, w of 2 cross this dot n. Okay, so a gap is the total is the side of a square. Except is the side of the square. Let's say this is gap, it will be much better, or side. Okay, now why I did 2 plus this dot n is one end will be positive, another end will be negative. So a frequency consists of a positive and a negative part, negative wave. So that's why I said 2 cross 2 2 into this dot n. So now we'll start a for loop. Sorry, I'm doing this in the update method, which is not good, right? Okay, this dot n. Now I'm going to begin the path. And so one amplitude will be positive, another will be negative, and based on whether I is positive or negative, is even or odd number, we are going to decide whether it's a positive or negative number. So we can say H is our Y is our. Before that, it must be in the middle of the screen. So we must say we must translate this to the middle of the screen. H by 2, okay, and y will be either positive or negative based upon your a, whether I is even or odd. So I will say I plus 1 minus 2 plus I percentile 2. This is a bit tricky formula, I'll get back to here. So so this formula, so suppose you have something called x. Okay, let me write here. So what did here is you have something called x, and you need y if and x is whether is 0 or 1. Okay, now you need y which must be 1 or minus 1 based upon x. So if you do 1 minus 2 cross x, so when 1 0 1 is 0 is when x is 0, then y will be 1 1 minus 2 of 0, which is 0, 1 minus 0, which will give 1. If x is 1, then y will be 1 minus 2 into 1, which will be 1 minus 2, which will be minus 1. So this formula basically states that. I will have this thing here for a better understanding. And I percentile 2 will give you whether it is odd or even. Now to draw a certain path, we have to call context at begin path. Now I will say context dot move to, which is gap into I. Okay, like this all will be after a certain gap, right? This all will be a certain that the distance between each gap will be gap, right? And we are starting from 0, so we are using gap into I. And first coordinate will be 0. Next we'll have 1 2 3 coordinates. One will next coordinate will be so next coordinate will be same, and it will be like in same gap plus I. Okay, so here's the trick. If it is a square, then the coordinate of the first and second x coordinate will be same. The second and third's y coordinate will be same, but x coordinate will be different. But here the second and third's y coordinate will be same, and the x coordinate will be also same if it's a triangle. And when we're changing our to a square, the x coordinate will be different. So we'll have 3 vertices for sure, but this will be a bit tricky now. We can safely say let's indicate that we have 3 vertices. So we can easily figure out the last vertex. So the gap between these two will be gap. Sorry, I'm using this side, right? So why I did this? So this gap between this thing will be side, like the difference between the only x coordinate will be different for fourth and first vertex, and y coordinate will be same, 0. So only there will be a difference of side of length whose value is side between the first and fourth vertex, and only x coordinate will be different. And here we can safely say the y coordinate will be same, which is this dot a. So yeah, so so here, so yeah, we as we are considering amplitude, the side, oh, it may not be a square. So here's the trick. This may not be a square, but it will be a. So generally, I was indicating a square because generally in physics or anywhere, we are anything which is rectangle, we say that as square, right? So that is the main thing. Otherwise, there's no correlation. So it will be not this dot, it will be y. So y can be positive or negative, like it can be positive this dot a or negative this dot a, based upon the I, whether it's even or odd. Now, when it is a square, when it is the triangle, it will be in the middle of the midpoint of the middle point of the x. It will be the middle point of the x coordinate of the first and fourth vertex, which is side cross I plus side by 2. Okay, since this vertex is for both of them are changing, it will move the same distance in opposite direction. So we can indicate this will move in the positive. So this can move in the negative direction. This is the second vertex, and this will move in the positive direction since it is in the negative. It is in the third vertex. So it will move a distance of side by 2, and this will side by 2 will be changing from side 0 to side by 2. So how we are going to document this change? We are going to use the scale variable of this dot state. So say now this dot state of scale cross side by 2. Okay. this is both are going to move in the same direction, in the opposite direction, from same distance in the opposite direction. Now we are going to just stroke it. And it will be better if you specify the style of the wave, like how you're going to stroke it. So we have to have some indicate some stroke style. I will say let's have till. Okay, and let's have a line width of side by 10 or side by 12 will be better. And let's have a line type, like the when in the edges of the lines, right? Let us have something rounded. Okay, this is like a very simple context of, if you don't have much array, you can check the documentation for HTML canvas. And so basically you got it. The thing is, the main catch is like there will be four coordinates from the beginning. The second and third x coordinate will be same. Now, when we are changing to a square wave or something called rectangular wave, we are moving the second and third direction some say the same distance in the opposite direction. So this is the most important thing. Same distance, second and third vertex will move. Let's have it here. Second and third vertex will move the same distance in opposite direction. And let's have some hide nodes here. One frequency will have positive and negative wave cycle. Okay, so we are going to add this to our Git repo in local Git repo. Triangle to square wave class. Now whatever we are going to do, we are going to do in this this thing, we have to communicate between this square wave GIF class and triangle square to square wave. We'll use a middleman called renderer, which will have a constructor. Okay, say this dot is running, and a render method. So this will we'll run a continuous loop here based upon is running. Okay, we'll have a callback method, we'll have an update callback method, and an end CB, like end callback method. So basically this update callback will be adding a frame to a GIF encoder using context. And let's pass the context object here also, like be much better. Okay, so we are going to pass this context to the frame of as a frame to the GIF encoder, and end CB is like basically we are going to do we are going to end the GIF encoder, which is here. So mostly this will be update CB and this will be end CB. Okay, and this middle thing will be present in our while dot this is running within this loop. So this renderer, in this renderer class, we are going to create a web object, the triangle to square wave. Triangle to square wave. Okay. Now we are going to draw the sorry, this we have to draw text. Okay, and we are going to say this dot uh, also we are going to say this dot web update, and we are going to pass a callback method here, which are going to which we are going to end the we are going to call the end callback, and we are also going with we are going to call the update cb after it iteration. And let's do this here. This dot is running as false. We'll break up the loop and we'll call the update cv and pass the context object, the updated context object. Okay, so this renderer will act as a middleman between this wave and our GIF class, triangle to square wave GIF class and triangle to square wave. Let's have some comments here. Update cb is adding frame to context. End cb is ending the GIF encoder. So we are going to add this to git adding render class. So we are going to create a render object in this create method. New renderer. Okay, and let's remove all this thing. Okay, now this dot renderer, simple thing, just will say pass the this dot context object, and we are going to call two callbacks. One is update cb, another is end cb. End cb basically is the encoder, and update cb basically takes a context variable parameter and just adds it to the GIF encoder as a frame. Okay, let's add whatever changes we did in the Git. Using render class in triangle 2 the main thing is testing, and I am quite sure that I'll have a lot of bugs, but I'll fix it once. Okay, sorry, this is a very common mistake. Yeah, there will be syntax error, this will be logical issues, lot of things I have to figure out. Okay, it has created a certain thing. Now let's refresh this thing. So we get nothing. So there may be slight issues or something. I will just say the issue. Let's put a console method here. Yeah, it is going from 1 to 0 to 0 to 1. If you have a console log, you can see whether this will be 0 to 0 and 1. Okay, it is going to 0 to 1. then 1 to 0. And as you can see, there it won't be the exact thing. There will be uh, some there will be some difference. Exact precision is not, there won't be exact precision JavaScript float thing, and I am not sure whether why it is not coming. Because, most of the thing we have done here, it should come 0 to, I have to check code here if I have done something wrong. Yeah, I have done something wrong, and because the issue is, okay, the issue, I need amplitude and frequency to pass, and this will be nan now. This dot a and this dot n will be nan or undefined. Yeah, it will be undefined. So I'm going to pass am dot frequency here. I am going to create this here, and I'm going to pass from the main class. So let's run this. Okay, there will be some issue because we have to clear the rect also. Okay, there will be a little bit of issue. So what we are going to do is, we have to clear this screen regularly. So how we are going to do is, we are going to use certain this, but not this one. We'll remove this one and say, uh, so what I want to, okay, that is a common thing. Okay, let's do this. You have to draw a background continuously here, right? Okay, in this main while loop, you have to draw a background. Let's say it is hash 2 1 2 1 2 1. Yeah, we have to run this script also, and we have to pass the context object. To pass this dot context here. All silly issues now we're getting. Basically, I'm feeling quite sleepy now. And it's good, but I want to change certain things. You can just test. I'll say 10, right? Oh, I can do one thing. I can make this all common. I'll say 50 or 25. So this looks a proper square wave. I can do much better. I can just say, let's say have 50 here and 5 there. This will look a proper square. So this looks a proper square wave for now. and I can change the speed delay. Let's say 125. This okay, it looks quite slow. I'll say 70, 80 milliseconds. Yeah, this looks good. So I'm going to add this my to the get local get repo, adding animation and drawing fixes. So, and also let's add the test files. Adding test files. Okay. So I'll also create a remote GitHub and share the link in the description. So I'm going to create triangle to square wave gif. Give a proper description here. Create a square wave outline. Simulation gif. Create a gif. Of us. Triangle wave to square wave. Okay, I'm going to create this repo. I got a link for the new repo which no commits, and I'm going to add this remote. So I'm pushing from the local repo to the remote repo. Okay. I'm creating a remote anyway, having the URL of the remote repo. I'll do just git push. I'll push the master branch there. And just refresh this page. So yeah, so you'll get all this lib folder. So this is basically the thing. This is the whole file which I have updated in the GitHub repo. So this is the link. So this is the link, and I'm going to share this in description. So this is the whole thing which are done. So I created a triangle to square wave gif, which is a main class, and I've created a state class which will track the state change from 0 to 1 and then from 1 to 0. and this is the part where I'm drawing, and I'm calling the updating the state triangle to square wave. And triangle to square wave is the one where we created all our GIF encoder and canvas, and we are going to use we'll create an object of renderer which I've created here. So this will create a while loop which will be valid when we change when our state from 1 to 0 is, from 0 to 1 and then 1 to 0 is reached, and it will valid till that. After that we're ending the GIF encoder, and when we are doing in the when in the loop we are doing updating the state and drawing the in the canvas, we are also updating the we'll also adding it as a the context as a frame to the GIF encoder. So yeah, so that was basically about how to create a GIF in nodejs and how to you can create from triangle an animation for triangle to square wave. So yeah, that's basically that, and I'm done for that. I am done for this video. If you have any issues, you can write in the comment, or you can go to my Twitter account and tweet me about this video. You can also follow what I've written, the code I've written in the GitHub repo which I just created in front of you. So that's basically, and do subscribe the channel if you find this video helpful, and do share it and like this video. So thank you and have a nice day.